Practical Electricity Part 1. Okay, in this section, we'll be covering about the calculations required for practical electricity. So before we start, let us do a very quick recap of what we have learned about practical electricity in our lower sec science. Okay, we have learned that there are 4 different effects of electricity. Okay, there is the heating effect, lighting effect, sound effect, and chemical effects. Okay, so how can electricity create a chemical reactions? Which of the following appliances makes use of the chemical effects of current? Okay, the answer is electroplating. Okay, so for both electrolysis and electroplating, it makes use of the chemical effects of electric current. For electric fan, it makes use of the kinetic effect of current. Electric bell, it makes use of the sound effect of current. And for electric iron, it makes use of the heating effect of current. Next, question number 2, power is defined as the amount of energy transferred by an appliances per unit time. The answer is true. Okay, power is defined as the rate of energy conversion per unit time, or the rate of energy used up by appliances per unit time. Okay, so in this first part, we'll be covering what is electrical heating. Okay, we will only be looking at the heating effect of electricity. We will not be focusing on the rest, like chemical effect, sound effect, light effect, etc. And then we will also zoom into how is electrical consumption being measured and how do we calculate the cost of our electricity. Okay, so these are the learning outcomes. Okay, so the first part, okay, we are zooming into what is electric heating. So we know that energy is transferred electrically to the internal stores of heating elements for appliances that makes use of the heating effect of electricity. So heating elements are usually made from long resistance, from long and thin wires that has very high resistance. They're usually made of nichrome or iron, chromium, aluminum alloys. So what happens is all these heating elements usually have a very high resistance. So when the current flows through them, it results in a lot of free electrons bumping into the ions. And this will in turn causes the ions to vibrate more vigorously, which raises the temperature. So the energy in the internal stores of the element increases, causing the heating element to become very, very hot. Okay, besides having high electrical resistance, usually most of these heating elements have a high melting point, so they will not melt when they reach a high temperature, and they also do not rust at a high temperature. Okay, so we are going to zoom into some formulas that you'll be learning in this chapter. Okay, I will not go in depth into how are each of the formula derived, okay, because you do not need to know that, but we will just zoom into what are the 6 formulas or 7 formulas that you need to know. Okay, so the first one you need to know, power is defined as the rate of energy conversion. Is how much energy is being converted every 1 second. So we have power equals to energy over time. And when we switch it, okay, based on this formula, power equals to energy over time, we get energy is power times time. Then we come into the 6 other formulas. Okay, you need to know that power equals to VI. Okay, and then from power equals to VI, okay, which is the voltage times the current, I can switch to power equals to V squared over R as well as power equals to I squared over R using the formula V equals to IR. Okay, so with V equals to IR, I can switch between these 3 formulas. And then, but sometimes I'm not interested in calculating power. I'm interested more in the amount of energy being used. So, and you know, energy is power times time, PT. So, in order to get, in terms of energy, everything I just multiply by the time. So, energy equals to VIT, energy equals to V squared over RT, and energy equals to I squared RT. Okay, So some of the symbols used in all these formulas, P is the power, SI unit for power is in watts, energy is E in joules, T is time in seconds, I is current in ampere, V is potential difference in volts, and R is the resistance in ohms. Okay, so let's look at a few examples of how we are supposed to apply all this formula. The first question, a filament lamp is rated at 60 watts, 240 volts. What is the current flowing through the lamp? So when the filament lamp is rated at 60 watts, 240 volts, it simply means that in order for this filament lamp to have the normal brightness or normal operating condition, in order for it to shine normally, okay, it's best that I plug it into a 240 volt supply, and the power of this lamp is 60 watts. So to find the current, I will use the formula P equals to VI. So I want to find I. So I equals to P over V. So it will be power or voltage 60 over 240 volts. I get 0.25 ampere. Next one, part B, I want to find the resistance. So I'm going to use R equals to V over I. So my V is 240, my I is 0.25, I get 960 ohms. And then the last part, part C, I want to find how much energy is being consumed by the lamp in 1 hour. So the energy is PT. Okay, I will just take the power, 60 watts, times the time. Okay, 1 hour, I need to change it to seconds. So it's 60 times 60, 3,600 seconds. I get 216,000 joules of energy. Okay, you may pause the video now to think about the answers to these questions. Okay, I'm going to go through now. You may check your answers. I'm not going to go through in depth for each one of them. The first one, an electric iron has a heating element of resistance 60 ohms. If the operating current through it is 4 ampere, calculates its supply voltage. So I'm interested in voltage, V. Okay, so I'm going to use the formula V equals to I times R. IR. So it's 4 times 60, I will get 240 volts. Next one, I will go and calculate the power. Power equals to VI. So it's 240 times 4, I get 960 watts. And lastly, the heat energy. Energy is power times time. So I use 960 times time, 5 minutes times 60 seconds. Okay, 960 times 5 times 60, I get 288,000 joules. For the next question, I have a resistance of 38.4 connected across a 240 volts power supply. Calculate the current. So I'm going to use I equals to V over R. So it's 240 divided by 38.4. I should be able to get 6.25 ampere. Next one, the amount of heat energy produced. Again, energy is power times time, or in this case, I do not have power, so I'm going to use VIT. Okay, power equals to voltage times current times the time. So I'm going to use 240 volts times 6 times 6.25 times time, 1 minute, which I must change to seconds, which is 60 seconds. Or I can use V square over R. Okay, V square 240 square over R, 38.4 times time, 1 minute, 60 seconds. Okay, and then the last one, I have an iron rated at 240 volts, 1 kilowatts. So under normal working conditions, find the resistance. Okay, so in order to find resistance, I can use power equals to V square over R. So 1,000 ohms equals to 240 square over R. So I can find the resistance. Okay, I'll get the resistance is 57.6 ohms. And then next one, the amount of heat energy being produced in 5 minutes. Energy is power times time. So it's 1,000 watts times 5 minutes, which is 5 times 60 seconds. I get 300,000 joules of energy. Okay, next one. I have a light bulb rated at 60 watts, 240 volts. So this light bulb will work best at 240 volts and has a power of 60 watts. Which solution below for the current flowing through the light bulb is correct? Okay, so I have three possible solutions. Okay, the first one and the second one, I'm just going to use power equals VI. Okay, and then I'm going to use the power of the battery of the light bulb, 60 watts, and then the voltage. I either use what is rated as the voltage for the light bulb. Okay, 240 times I. Okay, or I use what is only supplied in the circuit. In my circuit, I only supply it with 120 volts. Okay, or solution number 3, whereby I have the power and the voltage. I find the resistance of my light bulb, and then I use V equals to IR. Okay, with my V being 120, and I use my resistance of my light bulb, I get a current flowing through my light bulb. Okay, you may pause the video to think of a short while for the answer. I'm going to go through now. The correct answer should be solution 3. Okay, so if this is the rating, it means that, okay, if I were to use the first solution, P equals to VI, whereby I use 240 volts, this will be accurate if the current, this will be the current flowing through the light bulb if my supply voltage to it is 240 volts. Then I will use I equals to power over voltage, 60 watts over 240 volts. I get the current flowing through this light bulb if I supply it with 240 volts. Okay, but the problem is I only supply it with 120 volts. Okay, so what happens is at 120 volts, my power will not be at 60 watts as well. It will be operating at lower power. So the only thing that is constant between the light bulb for this light bulb is the resistance of the light bulb, which cannot be changed. So the first step, I will to calculate the resistance of a light bulb, okay, based on the rating given. So the resistance of light bulb is 960 ohms. This resistance cannot be changed no matter what voltage I apply across to it. Okay, it's a fixed property of the light bulb. And with this resistance, and I have a voltage of this 120 volts, I can then calculate the current flowing through it, which is 0.125 ampere. Okay, next for example, you may pause the video to think about the answers. Okay, I'm going to go through now. A 3-liter water tank is heated by a heating element of resistance 80 ohms connected to a 240 volts mains. Calculate the electrical power produced in the heating element. So I'm interested in power. I have the resistance 80 ohms and I also have the voltage 240 volts. I'm going to apply the formula power equals to V squared over R, since I have V and R. So it is 240 squared over R, 80 ohms, I get 720 watts. This is the power of the heating element. Okay, let's go back. Calculate the amount of energy transferred to the internal store of the heating element if the switch was turned on for 10 minutes. So I'm interested in energy. So energy will be equals to the power times the time. So I have my power calculated in part A times the time, which is 10 minutes. Obviously, I need to change it to seconds. So 10 times 60. So I'll get 720 times 10 times 60. Okay, I'll get my total amount of energy is 432 kilojoules or 432,000 joules of energy. Okay, next part, part C. If the energy in the internal store of the heating element is all transferred to the internal store of water, so the heating element transfer heat to the water to boil the water up. Determine the increase in the water temperature. Take the density of water as 1000 kg per meter cube and the specific capacity of water as 42,000 joules per kg Kelvin. Okay, so I'm going to I need to determine the increase in the water temperature. So this one goes back to the thermal properties of matter. Okay, you have learned that the heat energy Q equals to MC theta. So I'm going to apply to that. So with a 3-liter water, okay, you should know that 3-liter first step is equivalent to 3 kg of water, given the density of water is 1000 kg per meter cube. So there is actually 3 kg of water inside the 3-liter tank. So the amount of heat energy supplied to the water is the amount of heat energy supplied to the heating element, which is 432 kilojoules, calculated in part B. So I'm going to sub everything in. Q equals to mc theta. Okay, so my Q is 432 times 10 to the power 3 joules equals to the M mass times C 4200 times the change in temperature. So the change in temperature is actually 34.3 degrees Celsius or 34.3 Kelvin. Okay, so next part, okay, we have calculated about, we have talked about energy being produced by electrical appliances as well as power. Okay, so the main formulas is P equals to VI and energy is power times time. And from there, we derived all the other 7 equations based on V equals to IR as well. Okay, the next part, okay, we need to learn that electricity consumed is not measured in joules, although we always calculate energy in terms of joules. But we consume electricity, we don't measure them in joules because most of the household appliances are being switched on for 24 hours. For example, your refrigerator. Okay, it's switched on for 24 hours. If I were to calculate the amount of electricity consumed in your household, then in joules, then it will be a very, very large number because 24 hours is don't know how many seconds, 24 times 60 times 60 seconds. Okay, that will be a large quantity. So usually when we measure how much electricity does your home consume, we measure them in terms of kilowatt hours. So you should know that 1 kilowatt hours is equivalent to 3.6 megajoules of energy. Okay, so how do I get this 3.6 megajoules of energy? We know that 1 kilowatt hour, okay, we know that energy is power times time. 1 kilowatt hour is simply 1 kilowatt power times the time of 1 hour. So 1 kilowatt is actually 1,000 watts times 1 hour, which is 3,600 seconds. So if I were to change it to power times time in terms of watts and seconds, I get 3.6 times 10 to the power 6 joules of energy. Okay, let's take a look at this video.
Have you seen these labels before? These are energy labels issued by the National Environment Agency, or NEA, for household appliances such as air conditioners and refrigerators. Each label shows the estimated energy consumption and the cost of an appliance in a year. The more ticks an appliance has, the more energy and cost efficient it is. In this video, I will show you how to calculate energy consumption and the cost of using electricity, and explain why using energy-efficient appliances is important. This demo kit is a simulation setup consisting of main household electrical components put together into a single panel. I will be using the electricity meter and power points. Let's calculate the energy consumption of boiling water. This electric kettle has a power rating between 1680 and 2000 watts. For calculation purposes, I will use the average value of 1840 watts. I will boil 1 liter of water using this kettle. The initial reading on the electricity meter is 0.910 kilowatt hour. I will now start the boiling process. It takes about 3 minutes and 19 seconds to boil 1 liter of water. The final reading on the electricity meter is 1.010 kilowatt hours. The energy consumption in joules is calculated as power in watts multiplied by time in seconds. In this case, the energy consumption is about 366,000 joules. Notice that calculating energy consumption in joules gives us a very large value to handle. For practical purposes, we usually calculate energy consumption in kilowatt hours. The energy consumption in kilowatt hours is calculated as the power in kilowatts multiplied by time in hours. This gives a value of 0.102 kilowatt hour. You see that calculating in kilowatt hour gives us a much smaller value that is easier to compute. Let's compare this value to the actual energy consumption using the readings from the electricity meter. The actual energy consumption is the difference between the final and initial electricity meter readings. This gives a value of 0.100 kilowatt hour. You can see that the calculated energy consumption is very close to the actual energy consumption from the electricity meter readings. This is a utilities bill of a 3-room flat for the month of October. The cost of electricity is 20.30 cents per kilowatt hour. Based on the actual energy consumption in the previous experiment, it costs 2.03 cents to boil 1 liter of water. You can also estimate the cost of operating an appliance using its power rating, the duration of use, and the cost of electricity per kilowatt hour. In this segment, we are going to compare some properties of an LED bulb and a filament bulb. Let's calculate the energy consumption of LED bulb over a period of 10 minutes. After 10 minutes, the energy consumption of the LED bulb is 0.002 kilowatt hour. The LED bulb has a maximum intensity of about 19,540 lux. The temperature of the LED bulb is 22.3 degrees Celsius. Let's calculate the energy consumption of this filament bulb over a period of 10 minutes. The energy consumption of the filament bulb is 0.018 kilowatt hour. The filament bulb has a maximum intensity of about 15,400 lux. The temperature of the filament bulb is 31.8 degrees Celsius. In summary, an LED bulb is brighter, generates less heat, and uses less energy than a filament bulb. Hence, we should switch to using LED bulbs if possible. The next time you shop for household appliances, remember to look out for those with more ticks on their energy labels or appliances that work at a lower power rating.
Okay, so in the video, they have summarized out electrical energies are sold in kilowatt hours instead of joules. So how do I get kilowatt hours for energy? Energy can also be, so that the other formula for energy in terms of joules is power times time. And another formula for energy in kilowatt hours will be power in kilowatt times the time in hours. And in order to calculate the cost of using the electrical appliances is dependent on how much energy you use, the amount of kilowatt hours that you use, times the cost per kilowatt hours, because electricity are sold based on kilowatt hours. So let us do a few examples. You may pause the video now to think about the answer to the last column. I'm going to go through now. So in this first case, I have an aircon with a power of 1,500 watts. I switch it on for 8 hours. So the amount of energy that I use in kilowatt hours will be 1.5 kilowatts times 8 hours. I will get 12. Next one, I will have 200 watts, which is 0.2 kilowatts times 24 hours. I get 4.8 kilowatt hours. And next one, the fan, I'll get 0.05 kilowatts times 8 hours, I get 0.4 kilowatts hours. And the last one, the iron, is already in 2 kilowatts, but the time I use is not even 1 hour, it's 30 minutes, so it's half an hour. So 2 times half an hour, I'll get 1 kilowatt hour. Okay, so next question. Over here, if PUB charged 22 cents for each kilowatt hours of electrical energy used, calculate the total cost of using a 3 kilowatt electric kettle for 20 minutes and a 100 watt filament bulb for 5 hours. So I need to calculate the amount of energy used by this electric kettle and this filament bulb first. So energy is power times time, and this power must be in kilowatts, time must be in hours. So the total amount of energy used will be energy used by kettle plus energy used by light bulb. So energy used by kettle will be 3 kilowatt times 20 minutes. So I need to change the minutes to hours, so 20 over 60. Okay, plus energy used by the light bulb will be 100 watts, so it's 0.1 kilowatt, or 100 divided by 1000. Okay, to convert it to kilowatts times 5 hours. So the total amount of energy that is used by both appliances will be 1.5 kilowatt hours. And since PUB charge it at 22 cents for each kilowatt hours, my total cost will be 1.5 kilowatt hours times 22 cents. I get 33 cents for using these two appliances. Next, you may pause the video to think about the answers to this question. I'm not going to go through in depth. I believe you should be able to calculate yourself. Again, I need to calculate the cost of using 240 watt lamp and 120 watts television for 5 hours in the entire month of April, where there is 30 days. And the cost of 1 kilowatt hour of energy is 13 cents. So the first step, again, I'm going to calculate the total amount of energy that is being used by the lamp and the television. So the total power that is used by both is 2 times 40, which is 80, plus 120 is 200 watts. Okay, so I have 200 watts convert to kilowatts is 0.2 kilowatts times 5. Okay, so I will get 0.2 times 5. I will get how much? I will get 1 kilowatt hour. Okay, and I need to use it for 30 days, so I'll get 30 kilowatt hours. Then I will have times 13 cents because 1 kilowatt is 13 cents. So I have 30 kilowatts and 13 cents, I get $3.90. Okay, the next one, you may also pause the video to think about the answer. I'm not going to go through. Okay, you should be able to get a final answer of $30.20. Okay, next example. If an aircon draws a current of 10 ampere from a 240 volt, means what is its power rating? So I'm interested in finding power. So the first one, power equals to VI. So 240 times 10, I get 2,400 watts. And then the aircon is turned on for 8 hours a day. What's the daily cost of electrical consumption if electricity tariff is 20 cents per kilowatt hours? So I need to find the cost of using this aircon. First step, I need to find the energy used by this aircon in a day. So energy is power times time. So I have the power is 2.4 kilowatts times 8 hours. I get 19.2 kilowatt hours in a day. And then 19.2 kilowatt hours, since electricity is sold at 20 cents per kilowatt, I times 20 cents, I get $3.84 a day in using the aircon for 8 hours. Okay, so we have finished the first part about calculations.